Welcome everyone to this week's IPLD Sync meeting. It's October 5th, 2020. And as every week, we go over the stuff that we've done in the last week and plan to do in the next week, and then discuss any open agenda items. I, of course, haven't opened the HackPad, but I remember what I did last week. So I spent still a lot of time on the Rust multi-hash stuff. And so the good news is it's finally merged. So tiny multi-hash probably won't be a thing anymore, but it's now fully upstreamed into Rust multi-hash. And so the tiny multi-hash stuff was kind of the work of 4 or 5 months of coding and prototyping and changing the APIs almost every week. But I think now it's stable enough to get upstreamed. So this is done. It's not released yet. There are still small items that I want to fix before it's actually released in order to make sure that we don't break any upstream users on Rust multi-hash. Yeah, and the other thing I did is I wrote an exploration report about IPLD data model numbers and IPLD codecs, which got simpler than I expected when I was writing it, because like my head was kind of like blowing up because it was so full of information about numbers. And so I suggest that people are reading it. I think it got interesting. And so the long story short is that if you use the data model, you should, and you want to encode it, just use a single type for integer and a single type for floats. And for integers, probably varins, and for floats, it's IEEE 754 double precision integers, floats. Yeah. Okay. That's all I did. Next week, I will spend some time on the WASM stuff, and probably also like on, which is connected on DAG, on SimpleDAG, and expect that also more PRs are coming based on my exploration report on existing specs. All right, and that's all I have. Next on my list is Zoom and tiling window managers don't work well. It's a rod.
So I just tied it up, DAG PB. That's, I don't know if that's published yet, Michael, but that's on you. And just working with the latest JS multi-format stuff, and DAG JSON, there's a pull request in to get that switched over to. So that's all 3 major codecs that are in sync and ready to go for the multi-format stuff. But I spent most of the week in Go, being an unproductive Go programmer. I was mainly looking at this question of codecs and writing codecs for IPLD prime, what that means, what it looks like, what are the implications of various decisions, mainly from the perspective of DAG PB, because that's where my head's been. And struggling a little bit against trying to, partly it's a Go programming model concern, but just trying to get things properly separated out. Like the temptation is to just put everything in together, and I just so uncomfortable doing that, just in programming in general. And so trying to find a model where pieces can be separated out, and that's been quite difficult. Looking at other codec authoring things with IPLD prime, participating in the discussion about pretty printing and DAG JSON and Clean 8, which I think Eric will talk about. And also, so this week, yesterday was a public holiday, so I did very little yesterday, which is my Monday. And this week's the last week of the school holidays, and so I just want to warn that I'll be a little bit more reduced hours than normal this week. But aside from that, nothing else. I think this week I'll be continuing to spend time in Go. So I don't expect huge output. So that's just been the nature of my time in Go. It's not been super productive. But I'm narrowing in on some other codec questions. Looking at DAG JSON at the moment, actually. That's been a bit of a distraction, but DAG JSON, DAG PB is where I'm at. That's it for me.
Thanks. Next one is Michael.
Yeah, so last week, as Rod kind of mentioned, I mainly spent the time getting the block interface ported over to the new multi-format stuff that Gozala did, and getting all his work merged. That's all in. It's ready to go. I had a call with Gozala today, though, and he's going to give me some more feedback. And then I think what's going to happen is we're going to take that block class and we're going to move it into multi-formats, because it'll actually be possible for you to instantiate these now without having like any of the registry or anything like that on top of them. So we just want that to be like a very simple type that you can pull out and instantiate, so that something like Rod's car file thing doesn't even need to import the block and the registry and all that kind of stuff. It can literally just be like, no, this is all we're doing. Yeah, so that's cool. That's going well. That'll land tomorrow, I think. I think that's when we'll finally land. And I had something else. Oh yeah, we have a new team management page. I think everybody on the call saw it, but that's like what I'm going to use at least through the end of the quarter, updating every time that there's any adjustment to what people are working on and why. And if we didn't capture a lot of your maintenance burden, or we just don't capture very well like how you spend your time, please send a pull request to that so that we can capture that more accurately. It's better for some folks than others, because some people just have a more difficult workload to capture, to be honest. Yeah, but anyway, just improve that. And then yeah, reviews are happening. Lots of management stuff is happening that I've had to deal with. So that was most of my week.
Thanks. Next one is Chris.
Hey guys. So I got the JS GraphSync spike completed, which was still mainly working through the P2P issues and my understanding of it. So that's good. Yay. And been continuing to log various GraphSync spec issues. So there's some issues out there, all consolidated all into an update of the specs later, probably once I think they've all been found for a certain iteration. I did provide some support for the Filecoin browser retrieval guys on JSLib P2P stuff. I guess I'm an expert now after my 2 weeks of exposure to it, but so it's kind of nice to share some. And then wrote a design document on JS GraphSync and reviewed that with Michael, made a few tweaks, so kind of have a path forward now. So this week will basically be implementing JS GraphSync, since I know how the underpinnings work and I have a design in place. So that's cool. I think that's going to go pretty quickly, since that's something I can refactor from and make sure it's still working. And then I have a presentation with Rod on Wednesday about scalable IPLD, IPFS data ingestion for this Filecoin masterclass. So we got to create some slides for that. I guess Michael will be there too. And so have some. I thought it was going to be Friday, so I just realized it was Wednesday today, so I crank on that pretty quickly. So that is my update.
Thanks. Next one is Eric.
Ooh. So I've just done lots and lots of communicating stuff this week. We had a meeting between me and Will Scott and MV Dan about ADLs and where to go with them. And so that discussion kind of came in two big parts, and trying to like bridge towards the middle of what we expect the interface of these things to be from what we can understand looking at things from the library design side, and then getting lots of information exchanged about like how a project such as the state diff that looks at Filecoin data, for example, might want to actually use the things. And I think fortunately, those converge without a lot of comment. We got lots more detailed information for us in the IPLD team about what Filecoin is doing and some of the the application level semantics that drift into view a little bit, as well as a couple of advanced layout stuff that is a little bit more interesting. Like there's some recursive advanced layouts in Filecoin. We're going to see how those go, but I'm hoping that those aren't actually going to be interesting. They should just work naturally in the IPLD constructions. We'll see. We'll see. So we got some notes on the ground to cover there, and hopefully we'll just keep slowly rolling forward on that. I'm really curious how the implementation side of things that MV Dan is working on is shaping up, but he's not here, so I will not speak for that. We have landed some new helpful tools in the Go IPLD Prime repo. So there's now a handy dandy function where you can take some arbitrary Go structure and you can hand it to the fluent.reflect method, and it will give you IPLD data model that roughly matches. It's full of magical reflection and do the right thing type logic, but it probably does the right thing. So the purpose of this is basically to use it in quick demos and like provide an onboarding ramp. It's not fast, it's not performant, but it does what you mean real fast. So hopefully it's good for demos and stuff. A bunch of internal communication stuff. I've started looking at Simple DAG, but I haven't published my notes on that yet. I don't know, Will, you haven't put any notes in the shared doc, but if you want to talk some about how state diff is going, I think that's been going really well, so I'd be interested in it.
Yeah, I don't know, not too much there. There is a schema for all of the V1 actor state, along with a lot of the other on-chain things like messages and how those go from tip sets to blocks to messages and stuff. So there's this IPLD thing. There's an evolving codec that gets a pretty printed JSON view of things that is more efficient than previously what we were having to do to make things work, which involved multiple rounds of like interface removing all types and munging things, which is a little icky. So now it's a trick of getting that used in various places that want to work with this data and see it in different places. So, yeah.
And we are making alpha usage of the Golang cogen stuff in order to pull this off, which is really exciting. Will's giving me lots of small bugs to fix and chase down to, some of which I've gotten to in reasonable time, some of which need to end up in a to-do list. But by and large, it's working. And like, I think most of the big questions we have are like, where do the ADLs fit into this now? So that's exciting. So the other big thing that consumed a lot more hours of my week than I expected was I'm afraid that I lit the fuse on a string encoding and escaping question and just character sets, and Rod is making a face where he's containing his laughter, and you know, several people are. Shoot. Yeah, so that's a fun topic. I tried to write a pretty print tool, and I think that has gotten into the weeds in ways that I'm not even going to follow up on. But it opened the can of worms on string escaping, and we're really going to need to enhance the quality and the detail and the clarity of the edges of how we specify strings in the IPLD data model. But generally speaking, it's come to my attention that a bunch of string escaping functions that I thought were capable of handling anything easily are actually not. Common string escaping systems such as JSON are actually really questionable out of the box. So we would like to define, I'm going to go on a whole rant for this, it might take a while. We would like it if strings could be defined as sequences of 8-bit bytes, because this is a very simple, clear definition. It does not necessarily map well to rendering cleanly, but it's a clear definition. It is generally lossless. It integrates with lots of stuff. Volker?
Yeah, so my first thought was, what is the difference between binary then? Because like for me, binary is 8-byte.
Very little, except for the intention that it should probably be printable. But I think it's important to, yeah, you still have to segment the dream of being printable from that's an implementation detail I want to push off just a little bit. So defining strings as 8-bit bytes is nice because it is so clear, and because there exist other systems in the world which are going to force us to deal with this anyway. For example, do you guys remember all the discussions about file names in the Unix FS v2 draft specs? It got really hairy. It turns out a bunch of file systems out there do not have very strict opinions on what sequences of bytes can end up in a file name, even though we would normally discuss this as a string. And this gets particularly impactful when we then mash this together with our definition of maps in IPLD, having string keys. And for example, wanting to use large sharded maps like HAMPs, which we want to use in a spec like Unix FE2, which still has string keys. All of these things are much simpler and more composable if we have this definition of string is 8-bit byte sequence. And a fair number of systems have no trouble with this. So like CBOR strings, for example, are instantaneously compatible with this and have no difficulties. The implementation of CBOR byte parsing and CBOR string parsing are literally the same function. They just have a different parameter for, am I going to call this bytes or string at the end? Same parse. So clearly it works for all of the bytes. Some of the codecs are not so simple. JSON does not support enough escaping for this, because JSON only supports such escaping as /r/n, these like super common special case ones. And it supports /u and then 4 hex characters, which is Unicode escaping, which draws from the Unicode tables. Not all bytes are valid Unicode sequences. It is therefore impossible in JSON to be constrained to the /u escaping rules and escape all possible sequences of 8-bit bytes. This is so very frustrating. I did not draw up examples on my screen right now, but I wrote some test case to prove to myself that this is actually as problematic as it is. And I swear to you, there exist sequences of bytes which you can describe in hex escapes, which you cannot, full stop, translate to /u escapes. So this is something that we need to talk about in our specs for IPLD, and we probably should draw up some recommended workarounds or substitutes, or just generally how we expect codecs should try to make this stuff behave when they have difficulty with 8-bit byte sequences and regarding them losslessly. There might be some good solutions out there. There's a thing called UTF Clean 8, UTF-8-C8 for short, which, as far as I know, was pioneered entirely by the Perl community, or at least all of the docs that I've seen so far are from them. And that appears to have a mechanism which does losslessly encode things. It's a bit interesting and a tad verbose, but it looks like it is lossless. So that's really exciting. We should look at that more. I think I'm going to wrap up that rant before I get more frustrated talking about it again, but it was fun to discover these things this week, and we should talk about and specify them more. I've come up with a new sort of rallying cry that I want to orient some of these discussions around, by the way, while staring at this. Normalization is mutation. I like it because I can chant it repeatedly if I have to. In IPLD, we're worried a lot holistically about making sure things have properties that favor convergence, things that make it natural to hash data and get reasonably consistent hashes out of them. These are things that make it nicer to build content addressable systems. But normalization is mutation. For example, if you force all strings to be normalized to, for example, UTF-8 NFC normalization. Necessarily, a normalization like this means you disregard whatever input you were whatever you were given, and you produce a new output. Normalization is mutation. If we want to losslessly regard data, by which I mean take some data that has been serialized, load it up, perform a no-op operation on it just for the sake of discussion, serialize it, and be able to hash it again, and perform this operation without loss, get the same hash, then we cannot mandate normalization because normalization is mutation. IPLD standards, in my opinion, should recommend normalization, but we cannot require it. Rant complete. Volker, you want to take the mic away from me?
No, it's just like it depends, because if this data was serialized at one point and it already had the rule that it need to be normalized, you don't mutate it because it was already normalized.
Yeah, but then you're in a happy
because it has
path.
to come from somewhere. But I mean, I totally understand your point. But
No. I think Eric's right though, in that even when it's lossless, you're still mutating it, right? When you're taking it from one state to another, you're still mutating it, even if it's lossless. If it's a lossless mutation, but it is a mutation.
Where it came from. Well,
if you're lucky, it's a no-op mutation, maybe. I don't know. But in general, normalization can happen to be no-op, but in general, you should fear losslessness. Normalization means that the domain of your function and the range of your function are not the same. And that means you're in danger.
Yes, so it's a bit about this do you have a bijective mapping between things? Kind of basically it's the same thing with numbers, which is my expertise. It's the same thing about if you have different flow types, do you normalize to the smallest one or not? Is kind of the same problem that if you do it, everyone has to do it, else you get different hashes for the same data. But I can see the problem, and so I'm excited to get on the next stage from numbers into strings. So,
but I think the same framework applies though, which is that we do need to realize that whenever you serialize something, you are mutating it, you are. It's just you may have found a lossless mutation, and that's great, and we should try to find all of the lossless mutations, but these cases where we have hash consistency are often because we don't have a lossless mutation, right? Or they can be.
As Peter has to hop off soon, Peter, do you have anything to share or say? Okay.
Nope. Not this time.
Okay.
Peter's launching Filecoin. That's his update.
Don't even joke about that. That's it's supposed to be in 2 weeks. No, 8 days. So should be all good after that.
I read in the news that it was in 2 weeks.
I read it on the internet. It must be true.
Okay. Is there any? Bye. So let's see. Are there any agenda items? I can't see any. So is there anything else people want to discuss?
I think it's just a half an hour of strings now. It's just.
I think you go on string.
I think I'm going to drop off then.
It's I have one more comment about strings because I'm still not sure why if we have the distinction between strings and bytes, you don't need the distinction between strings and bytes anymore if strings are 8-bit.
Something that the data model is supposed to help you along with is to find a way to losslessly do this mutation. There, Will's gone. That was funny. That's the point of the data. We need to, if it's not going to round trip, then we need to make it not part of the data model if we can, right? We need to find, or at least have some recommendation from people to have a way to do this and round trip it properly. And just saying it's always 8-bit it's just bytes now because they're all 8 bits, like doesn't do that, because you're going to have data that won't round trip through various string types.
But basically, if like, for example, the thing with the file names, then just say file names are bytes and not strings, because why should file names be strings?
We like presenting things. They're mostly strings. It's just that we cannot.
So there's 2 places where it matters. One is in serialization, and the other is in representation. But that representation also goes for in our own programming languages, where we like to have a string object, and when you put bytes into a string, they do funky things in different languages. So we can't always just keep them as bytes, because then we're entering esoteric land where no one will use our stuff.
Well, and also, like, we haven't actually solved this problem for anybody, because like we know that what everybody's going to do with a file name is convert it to a string. Like that's what you do with the file name. So like if it's not going to round trip properly through their application stack when they're doing this conversion, then we still have the same problem. We just pushed it up the stack, right?
We've said we can't deal with this. It's your problem. we're going down further. I don't think we want to be in the business of going further down. Like this point, just like the numbers thing, raises questions about what is our role and where is our stack, like where is our position in the stack, and what is it that we should be doing within that. Like we could spend a long time on this. Where's the point of diminishing returns where we say, okay, this is good enough? I don't know.
My opinions about this are mostly formed out of empirically what fucks with me the least. And the answer to that is actually really simple. It is regard strings as bytes and try to render them. That combination is actually really efficient. It's what CBOR does, and it works, and people seem to like it, because most of the time you say string in CBOR when you mean string and when you expect it to be rendered. And when you know you don't mean string and you mean binary bytes, you say bytes, and like maybe you expect that it won't be rendered so much. And so all the CBOR pretty printers respect those two things and highlight them appropriately, and it sort of does what you mean as a human, and everybody's happy. And like, I think that's basically just exactly the thing that we should follow because it works.
So as normally, like often the discussions are towards Go, I've started a discussion around Rust. So basically the problem will be if you do it this way, the things won't be strings in Rust. Like you just can't use those things. Like in Rust strings are strictly Unicode things. File names are special. File names are path, and they basically do weird tricks to basically make it work across bit forms, but they're not strings. For this reason, because like file names obviously are not fully Unicode. So basically in Rust, you wouldn't be able to use the native string type if we define the string as being
well, no, but isn't this what that thing gives us that you found, Eric, where you actually do have a conversion that will losslessly hold on to that code?
UTF-8 clean 8 does give a way to place arbitrary bytes in things that are regarded as UTF-8 strings.
So would it...
In the case of Rust, I would also seriously consider, I'm not super familiar with this, but I would consider using the Rust, whatever type it is that they use for file names, use that as our string. It sounds like it's correct.
Oh, they using the WTF8 encoding.
I'm gonna have to read about what Rust does with this.
Yes, so it's a WTF8 encoding. It's a good name because it basically does, it does strange things. So yeah, you can read it up, but it's not. So it doesn't support, I think, arbitrary bytes. But anyway, yeah, there's a good, like, I remember there's good documentation about what they do with the file name things.
Do they have it called OS stir? And can we use that?
Just search for WTF8. encoding or something. Yeah, this should bring it up.
I just posted a link. Like there's a link in the Zoom chat now to the spec.
I think this is the encoding they actually settled on for file names. Yeah. So coming back to, so if we use, so I haven't looked really into the Unicode. No, what is it called? Like the C8 stuff, UTF-C8. I haven't looked into it, but if it means that it probably round trips to, or it can be encoded as a proper Unicode string, then of course you could use the Rust string type on it. So is it, if I understand correctly, so if you don't have any weird bytes in it, it will still be like a normal string kind of thing? And if it has some whatever, you will have those like, yeah, those weird characters in, but it would still be fine.
Yeah.
Then it's of course fine, because like as long as like what I basically don't want is like I get a string from the IPLD data model, try to convert it to a string, and it will panic because like it's not UTF-8. But as long as like as long as it's like valid UTF-8 stuff, then that's totally fine, I think. Yeah.
I would say it seems unfortunate to me if a data model in memory has to use this. I've been hoping that it's something that we can use in codecs that have restrictions, but we'll see. It's somewhat surprising to me that Rust would have made a choice like this. I've heard people complaining about Rust and file systems, and I guess now I know why.
Yeah. Cool.
So Rust is our weak point here. That's really fascinating.
Well, hold on. Rust is one of the reasons why Rust has this is to deal with JavaScript's fucked up strings. Because JavaScript's strings are potentially ill-formed UTF-16. So literally, like, you can just jam like arbitrary bytes into them, and like we used to do that in Node. Like that was how we had binary in Node before buffers.
Isn't the way
and it was just terrible.
Isn't the way Rust does it also the way that Python 3 does it?
No. There's Python 3 is really strict about strings, and is it all UTF-8 now or all UTF-16?
Yes, I think so.
It's all some kind of. It's one of the Unicodes, but it's all no. It's Python 2 that had all this variation. Python 3 actually like was very strict about like everything is UTF-8 now, including the language itself interprets like string data as Python. It's only
yes,
UTF-8.
but this means that also then they have the distinction between, so in basically the problem between Python 2 and Python 3 is, or like a big differences in strings, that in Python 3 they are proper Unicode strings, and you have the distinction between Unicode strings and bytes. It's the same thing. Plus you have bytes and you have strings. And this is why I think like we're talking about like making, I'm not sure like if you're talking about this or not, that if we want to go into the direction of that our strings are more than Unicode, more than UTF-8, sorry. Our strings are more than UTF-8 things.
I think the problem is that they already are, because we're already seeing uses where they are, like Filecoin. And so we've left it open, and because we've not been willing to draw a line on this stuff. Maybe we should, maybe we shouldn't, but because people are going to push that, then our strings are essentially bytes that can be printed. So we have a choice,
and they don't round trip. And they don't round trip. Like that's the issue. Right. Is that like when you do this, they don't round trip. And like I think what Eric is saying is that like there is a utility that we could put in the encoder or decoder that just like handles that and always prints something that is going to round trip properly when people are doing these weird things with their string types.
I think we're going to need to generate a lot of documentation about this in textual form in the specs repo, and it's going to have to cover a lot of different directions. We're going to have to say what we want strings to be in the data model. We're going to have to say where codecs force us to compromise and what encoding escaping schemes we use when they do so. Mind you, escaping is distinct from normalization. Escaping is not necessarily mutation. We're going to have to say when that breaks down and have library author recommendations. And in as much as we regard implementation details of various languages, we're going to have to not just say what those languages say they do. I'm afraid we're going to have to look at what they actually do, because that is not always entirely one-to-one. So it seems to me. And the details there really, really matter. Like if, I barely even care if a language or a library or whatever says that it only accepts UTF-8. My reaction to that is, cool story, bro. I don't believe you. Tell me what you do when you encounter other bytes. And you have to go look at the code and see what that is, because documentation rarely says it, is my experience so far of looking at this. So for example, I strolled through a bunch of different string escaping functions in Go, and we don't have to hold these to perfect standards. Just because I program Go, I don't expect anyone else to care. But what I found is, for example, the string escaping function for JSON in the Golang standard library, if it encounters any bytes that are not UTF-8 sequences, it will throw them away. It will completely disregard whatever the content is. Why would I preserve data? And instead, it will escape /u FFFD, which is the character in Unicode. But it throws the original bytes away.
Mm-hmm. Yeah. So JavaScript has this thing where you can force a bunch of ill-formed bytes into the string, and they will round trip in certain places in the platform and not in others. So if you try to like concatenate strings, if you try to like actually get string representations, they get shed. But if you store them in index database, they will come back with all the fidelity that you've shoved into them. So one of the things that people do actually is that they have special compression libraries in JavaScript that compress into ill-formed strings, because they can get stored and round trip fine in index database. But if you do other things with them, then they break. Like I was trying to use that compression library once for some stuff in our stuff, and it was not round tripping. And I was like, why is this breaking? And like, yeah, that's why, because it's an ill-formed string.
All right. I saw that Johnny joined. Do you want to share something?
Yeah, so I was lurking on the YouTube channel, and so I think this is apropos to what I'm struggling with in the DID specification and lossless conversion between JSON and CBOR. And we're settling on an abstract data model, one which is just abstract, which is too hand wavy for me. I've been proposing CDDL for a while, so that's concise data definition language, and JSON being a subset of CBOR. As long as you have some rules in place, then actually there is lossless conversion. And the RFC 7049, the CBOR specification, actually talks about this, and I think certainly IPLD actually conforms mostly to this. But the CDDL, I think here it is, yeah, RFC 8610. So if you restrict things like integers have to be 64 bits represented even with integral values, that you have a constrained set that is losslessly compatible with JSON. And so the same thing with the JSON strings as UTF-8. The /u and other things are a little bit nuanced that I don't understand, but I think what I'm settling on is trying to say that the abstract data model is constrained to using CDDL as to describe the abstract data model, even though it's kind of like more syntax, but also somewhat classes and types. And I'm pitching it tomorrow and trying to get some feedback on it. Unfortunately, the CBOR guy, Jim Shad, just died over the weekend, and he was supposed to be giving me some feedback for my CBOR explanation. And I don't know what happened. I was waiting for feedback, and then I just heard from another colleague that he died, which sucks.
I wonder if it was something like COVID or something like that. It's really sad.
Yeah, no idea. He owned a winery, so actually, like, he was retired or from Microsoft, and he was basically doing CBOR stuff and IETF stuff on, like, just for a hobby, and he was running a winery in Oregon. And so I don't know what happened, and but it just sad news came through my newsfeed this morning, and just totally shocked me, and now explains why I haven't heard from him. But so CDDL, I think, again, like I mentioned this last week, was like similar to how you do at context for JSON-LD. It's like, you know, if you constrain your schema with a data definition, and that in that sense, JSON is a subset of CBOR, and you constrain the data types to those schemas defined in CDDL, then there is lossless conversion. Like CDDL actually facilitates that. But as soon as you get into like, oh geez, IEEE 754 for representing numbers, and trying to do conversion between that and 64-bit or 32-bit conversions, then it explodes really quickly.
I think I would offer that the idea of clearly specifying specific domains for this feature, like in the sense of a function has the domain of the inputs and the range of the outputs, right? If you specify narrow domains where you know things will work, and in that subdomain, then there's a bijection between your domain and your range, then you're good. You can use CDDL as a syntax for describing those domain restrictions if you want. I'm indifferent to that. I think if you wanted to make your proposal not depend on another spec of that complexity, then you could probably just use more simple language around domain constraints and probably get away with it. I don't know how complex of a thing you're specifying, so I don't really know how feasible that suggestion is, but like that would be something you can try to if you get pushback on that. But in general, yeah, constraining things, yeah.
Yeah. So relatively, it's actually just straightforward, or key value pairs mostly with strings. And so a lot of it is like trying to get JWK keys represented properly and explicitly state the syntax for representing a JWK, let's say, you know, ED25519 and RSA and SecD256K1, et cetera. And so, and I think what Jim had mentioned to me before was that, like, just do it in JSON. Like, don't try to do binary with tag 23 with expected encoding to base 64. It's like, just keep it in JSON. It's humor friendly. You get some compaction, about 25%, just converting it to CBOR, mostly because you're not dealing with any of the strings in JSON. And so I think it's cleaner, and there is overlap with the data model in JSON and CBOR. And then more complicated stuff, you just constrain, like, you know, numbers have, like, just like in the CBOR spec, and which I think IPLD conforms to, is that there's just more, the most simple representation wins. So the base, like, everything is base 64, bit 64-bit numbers. Don't try to do IEEE 754, and in which case you just have one way to represent numbers, and that basically then, and it's mostly we're not trying to boil the ocean, like, just keep it simple, and I think then everything will work out just fine. Right on. Agreed. Yeah.
There's overlap there with a topic that we've also got going, which is the float format in CBOR for DAG CBOR, trying to unify our codecs. Do we do small as possible, or just choose 64-bit?
Yeah, and this gets so if you guys actually do get a chance, if you could read what I wrote in the specification to make sure I'm conformant, because I wrote a bunch of stuff. I don't know how accurate I am to actually what that DAG CBOR actually does. I know DAG CBOR does most of that, but
yeah, okay. Well, you got a link for that?
Yeah.
Just so, on the numbers, when we're not consistent, which is the problem that we need to resolve. So our spec set, see, what we try and do is say, we've said we do strict CBOR and we follow the guidelines in the CBOR specification for what it means to be strict. So that's where we say strictness, okay, we'll take their version of strictness and do that. And most across our main codecs, we do that. Like so JavaScript and Go, we do that. It's just that the numbers we don't. So in Go, we do 64-bit, and in JavaScript, we do small as possible. The spec says small as possible. And so the question has been, do we conform Go to that, or do we conform JavaScript to our own version of strictness? And the discussion yesterday, I think it was Volker also bringing this up, that maybe 64-bit is the way to go. And we should, because I like that. I like 64-bit because it's simple. It means you don't, because when you do small as possible, you have to try and then fail, try, fail. There's two different, like 16-bit and then 32-bit, and then fall back to 64-bit. So it's intensive. It's not simple. There's no simple algorithm for that.
It's not that difficult. Like it's just 2-bit maps if you like to, because I looked into it, so you can do a bitmap check. Like you can basically do a mask over the raw bytes, bits of the do bit mask over the float bytes, and can determine whether it can be converted or not. I don't think that's right though, because you've got different lengths of mantissa, and you can't, like, for each of the different formats, you've got a different number of bits that make up the two portions. So you can't just say. Yes, you definitely have to check it for each smaller version. So basically, if you have a 64-bit, you have to check, is it 32-bit, is it 16-bit? Yeah, you have to do that. But you could also basically start with, is it, so you can directly check, is the 64-bit thing like does it fit into 16-bit? And if it doesn't, you check for it, does it fit into 32-bit? And yeah, so I think it's possible. So I haven't implemented it, but from like what I looked up, so if you want to read my notes about it, I can post you the notes about it. Right. And we do it in JavaScript, but it means doing an encode and then a decode to check if it fit. And then if it fails, you go up to the next size, encode and then decode. And then if that doesn't work, you go to 64-bit. So we do it fine in JavaScript. JavaScript works fine. And it follows the spec, the CBOR spec strictness recommendations that we have in our DAG CBOR doc. In Go, it's just throw this thing as 64-bit. Now I'd really like to unify this and fix it, but it's still unclear to me which one we should choose, because on one hand, I just think 64-bit is just the easiest. Just choose 64-bit and treat everything as 64-bit. Like that would be the cleanest. But the problem we have is that because the spec says the strictness should be this, then it's easier to find implementations that do this. For example, if we then go and say, okay, we've got to fix this in JavaScript, we have to go back into the JavaScript encoder and fix it there, which, it's not. and then everyone that wants to implement this in their own language would then have to go and implement this manually, because they can't just pull a strict CBOR parser off the shelf and use that. They have to but I think the float stuff is not part of the canonical CBOR, but I think it's part of the JSON to CBOR. I think it's part of the JSON to CBOR part. No, it's part of canonical in the spec. As small as possible. Okay. Yeah. Okay. Then yeah. But I think it also says you should pick, like, it's just an example of what you could use. Yeah. But that's right. But that whole section in the spec is example. It's you should do canonical, and here's some ideas. But then every implementation that does strictness says this is how we do strictness. So that makes it easier, which is nice if we can just piggyback that. Yeah. But it's not. Yeah. So anyway, I'd like to resolve that soon, and it either means going and doing Go, which is potentially easier because Eric owns that code, and that's easy to fix. The JavaScript one's a little bit more complicated, because even now there's a stalled pull request on getting that changed from buffer to UTF-8. UINT8 arrays. Like that, I think even just modifying that thing has become complicated. But I don't know.
anyway, this is a complicated area, and Johnny, I don't think we can help you on floats.
Yeah, so I mostly copy and pasted what was in the spec for canonical CBOR, but there's an updated draft that the author has written, which I think is still draft in IETF, which basically I think extends it, and I think and it gives additional guidance. But mostly I need to go through and just test to make sure that there is lossless conversion, round tripping it, mostly it's upfront constraints on how to represent it, and those constraints are explicit in the CDDL method to get lossless between JSON and CBOR. And then trying to leverage things like keys must be strings, and specifically in CBOR they must be byte arrays, and JSON they could be strings. And so but it's funny because we don't even have any numbers that we're trying to represent yet, and so this is all conjecture, and I think it's so trying to get to this abstract data model and boil the ocean without even this being a problem yet. But this is the nature.
Isn't that what the IETF's about?
Yeah, yes, exactly. And it's a painful process of futility, and which Juan warned me about.
So given my exploration report, I would expect that we hopefully agree on just using 64-bit floats. So just as a likely outcome, we might still decide otherwise, but I guess I'm also leaning towards just using 64-bit and be done. Yeah,
but we'll see. It's the be done bit that's difficult.
So before 5 minutes ago, I thought that use the smallest encoding was what the CBOR spec said in no uncertain terms, and therefore I was sort of on that side, despite having written code that does the simple thing that's 64 myself. Since we were talking about this, you're right, whoever said this part of the CBOR spec is all examples. I didn't remember how this part of the spec is. Yeah, it says if a protocol allows for IEEE floats,
it's hilarious,
then additional canonicalization rules might need to be added.
Such as?
Yeah, and then it's all examples after that. There's no pseudocode, there's no fixtures, there's no...
No, and it's, yeah, but without any other guidance, everyone's just taken that, which is fair enough. They just sort of gone a bit further and said, well, okay, here's canonical. This is how you implement canonical. But they didn't, and so everyone's just taken it as it is. So...
Yeah,
so I was going to reach out to Borman, who's the author of this. He's, I think, in Germany at a university, and just get some feedback about this for my specific protocol to make sure that actually I'm conforming to it in the absence of Jim, who died. I think he'll have some sympathy for me, I hope. I'm looking for some wisdom.
I had some email exchange with him to get the tag 42 reserved for IPLD and moved things around. So he was really easy to talk to, and super nice person. So yeah, it's cool. Super approachable. Yes, so I think this making the smallest float possible, I think, is needed for if you want to have canonical CBOR but still support all floating point types, then you need it. But if we say in DAG CBOR we only have 64 floats in CBOR, then our canonical representation is good enough for being canonical, basically.
So yeah, I mean, canonical just means picking one way that round trips cleanly. That's all it is. Actually, pick a consistent way.
Yes, pick a consistent way. But basically, if you want to have the support for, let's say, 32-bit floats, and you...
But the same thing applies to numbers. We could do 64-bit integers. And then in the language land, you have to, it's like what Eric's doing with IPLD prime. He's doing the data model, and there's just one type of number. And so when you get to the CBOR level, you just encode with whatever it has to do. And if we said in CBOR that you only had 64-bit integers, that would work too. It just means that on a language level, we have to deal with it in whatever way makes sense. The data model says numbers, integers. It doesn't say what size. And so you just use whatever size is appropriate for your thing. And usually that should be, I would say that should be biggest possible in your language. Although Rust, they kind of get big, don't they? They get 128.
Yeah, but only like kind of like you can use it, but normally you use 34. Yeah, it's 64. Sorry. Yeah. You could use 128, but you won't.
The number thing makes sense because, sorry, the integer thing makes sense because it's so easy to check. Because you just do a boundaries check. But with the floats, because you've got different size mantises for each representation, it just gets complicated. And you can get roughly the same number by doing the different encodings. It's just crazy.
For what it's worth, my skin has now easily swayed to simple is correct and always do 64-bit floats, because it does not directly fight the CBOR spec, and it is the simplicity arguments are swinging me.
Yeah. It has the benefit of being the thing that you would do anyway if you were just trying to get it done, which makes it much more resilient. So
which is why the Go one does it. Yeah.
Yeah. But like, I wish that the rest of the canonical CBOR spec was that way and didn't have all of these like complex rules about variations that people are going to get wrong, like just going to.
All right.
Especially if there's no penalty for getting it wrong. Like if it'll still decode and you get it wrong, you're fine. Like nobody cares except for us.
Well, I'm trying to get it right because they're trying to finalize and get this into candidate recommendation. And so I wanted to make sure actually I get it right. And I need to do a bunch of test cases, but to make sure that what I wrote fits. What I put in the chat is the updated draft, what Borman wrote about the additional considerations for deterministically canonicalized CBOR. So there's some additional things to consider.
Cool. Oh, here's another argument in favor of just doing 64-bit. I'm gonna paste this this thing in. This is the JavaScript. This is how it does the smallest possible, which is just crazy. The other argument in favor of going with just 64-bit is that many modern languages don't even include a 16-bit float encoding type, and so there has to be written. So you can do single precision and double precision, but you can't do half precision in a lot of languages. So like in JavaScript, you have to implement your own half precision encoder just to get half precision floats, which, like you're writing out the float format manually in that point. And so not only is it complicated algorithmically to do this, to get the encoding right, you have to, for the smallest one, you have to write your own manual encoder. So not good. It works, like you can make it work. This is not about whether or not you can make it work. It's just that this is a complex path. And if you're working with a CBOR encoder that already has strictness, like a lot of them do, then it becomes easy. But we're getting to the point now where we're starting to say, you really should probably be implementing your own CBOR parser if you're going to be doing DAG CBOR. So
yeah, I mean, so we've had to say for a while, and that's why it's like just not, it's not the best. It's the situation that we're in. We're gonna have to document it, and we're gonna have to like say all the things. We're not DAG CBOR isn't going away, but yeah, there's like a limit to what we can do here and what we can potentially recommend. So.
All right, we've hit the hour of the meeting. So thanks everyone for attending, and see you all again next week. Goodbye, everyone.
Yeah.